Today's notes are 1-7, finding a midpoint and the distance between 2 points. And your video notes today are brought to you by Cute Little Piglets. You have a graphic organizer today. I'd like you to glue it about 2/3 above the bottom of the page. And where that line is, I'd like you to extend it all the way through. So again, this is about 1/3 of the page. This is about 2/3 of the page. I also want to point out that sometime during these video notes, I'm going to ask that you return to 1-5 notes. And on this blank page next to your quiz, I'm going to ask you to write something there, but not yet. So on the top of your notes, I'd like you to write the title, Finding the Midpoint. We're going to look at how to find the midpoint on a number line and also how to find the midpoint between 2 points on a coordinate plane, so a slanted line. The first example is going to require that you copy down this number line and also that you copy down these 2 questions. So I'll give you a moment. Go ahead and pause and unpause when you're ready to get started. So what would happen if I asked you to find the midpoint of AB, segment AB? So let's write that in. Find the midpoint of segment AB. If you wanted to find the middle point, here's what I would probably do. I would take one endpoint and add it to the other endpoint, and then I would find the average of the 2 numbers. So I would take those endpoints, add them together, and then find the average. So for example, for this problem, I take the endpoint A, add it to the endpoint B, which is in between 8 and 10, so 9, and then I would divide that by 2. So in this case, my midpoint would be at 5/2 or at 2.5. And if I look on the number line, here's 2 right here. 2.5 is going to be right here. So it looks like our midpoint is right there. But what if I asked you to find the midpoint of a slanted line, like for example of segment FJ? If you want to find the midpoint of a slanted line, it's really similar to finding the average, but in this case, instead of having one value, we're looking at an x and a y value. So it's pretty simple. I think you'd probably come up with this too. If you want to find the midpoint between 2 coordinate points, here's what you do. The midpoint is going to be another coordinate point with the x value being the average of the x values, and the y value will be the average of the y values. So let's try this in action. Point F is at -1, 5, and point J is at 2, -2. If F is my first point, I'll call it x1, y1, and J is my second point, so I'll call it x2, y2. So if I put that into my formula here, the average of the x values would be -1 plus 2. Those are my x values divided by 2. And my y values would be 5 and -2, and then the average would be dividing that by 2. So what's the midpoint? Well, -1 plus 2 is 1, so 1/2 is my x value, and 5 plus -2 is 3. So my midpoint is at 1/2, 3/2. So 1/2 on the x-axis is about here, and 3/2 is 1.5, which is about right there. So if I find the intersection of those 2, this is my midpoint right there. Go ahead and mark that on your graph and we'll move ahead. Now for the bottom half of our notes. Go ahead and write the title, Finding the Distance, and then pause for a moment and we're going to go back to a different section of your notes. Okay, now's that moment. Go ahead and scroll back in your notes until you find your 1-5 notes, and go ahead and find Tier 2. I'm going to go ahead and move these piggies over where I want you to take notes today, right there. So on the page next to your quiz, you're going to write the title, Simplifying Radicals Review. You can take up the whole page if you want. And we're going to do 2 examples to kind of help get you started. Now, this is a review, so I hope you remember it. If you want to simplify a radical, you first have to ask yourself, are there any pairs of factors inside of 45? In order to find that, you're going to need to look into 45. 45, if I break it up, is 5 times 9. 5 is a prime number, but 9 isn't. It can be broken up further into 3 and 3. That means the square root of 45 is 5 times 3 times 3. So remember my question was, if it's simplified, then there will be no pairs inside it. Are there any factor pairs inside of 45? Well, the answer is yes. There's a pair right there. The rule is For every pair, 1 comes out. So for example, for the square root of 45, the 5 doesn't have a pair, so he stays under the square root. But the 3 does. For every pair, 1 comes out. That means 3 square root of 5 is the simplified version of the square root of 45. Now let's try the square root of 80. Let's see if 80 has any factor pairs inside it. 80 is 8 times 10, and 8 is 4 times 2. 2 is a prime number, 4 isn't, so break it up further, and 10 is 5 times 2. That means that 80 is the same thing as 2 times 2 times 2, that's from the 8, and then 5 times 2 for the 10. Okay, let's check. Are there any factor pairs here? Well, yeah, there are. There's a pair here, and there's another pair, even though they're not next to each other, right there. So again, the square root of 5 is going to stay inside of the square root. Remember, for every pair, 1 comes out. For every pair, 1 comes out. That means that this would simplify to 4 square root of 5. So square root of 80 would simplify to 4 square root of 5. Okay, we're ready to go back to our notes now. So the question now is, how do you find the distance between 2 points on a coordinate plane? So for this plane, what we're going to do is we're going to ask ourselves, how far is point B from point A? So let's go ahead and write that question. What is the distance or length of segment AB? So that's my question. If I were to connect B to A, what is the distance or length of AB? Pretend that's a straight line. Okay, in order to find the distance, we're actually going to use the distance formula. Later on in the school year, I'm going to show you where this formula comes from. Here's how it looks. The distance is the square root, okay, so the distance is the square root of the sum of the difference of the x values squared and the difference of the y values squared. So let's try this in action. First, I'm going to need to know point B and point A. Okay, point B is located at -4, -3, and point A is located at 4, -4. So here's how I make my life easier, because this is a very complicated formula. I go ahead and I set up my formula. I know that the distance formula always has a square root, there's always a sum, there's always a difference that's being squared, and a difference that's being squared. That means that I'll just be putting x values here and y values here. So let's go again and say that this is my first point. Excuse me, let me erase that. This is my first point. Hold on. There we go. I got this now. Here's my second point. And now I can put those values in there. My first parentheses will have my two x values, x2, x1. x2, x1. My second set of parentheses will have y2 and y1. That's -4 and -3. Now this is just a matter of using the order of operations. So first I'm going to take care of the parentheses. So 4 minus -4 is 8 squared. And -4 minus -3 is -1 squared. Next I use my exponent. So that's going to be 64 plus 1. That means that my distance is the square root of 65. Now before I can put a box around this and say, yes, this is the length, I have to check if this is simplified. So I'm going to go ahead and take 65, and I'm going to break it into its factors. Its factors are 5 and 13, both prime numbers. Are there any pairs inside of 65? No, there aren't. That means that the square root of 65 is simplified, and that this is the actual length. Now if you're asking yourself, whoa, what is the square root of 65 anyway? Well, you actually know. The square root of 64 is 8, and the square root of 81 is 9. So that means that the square root of 65 must be pretty close to 8, closer to 8 than to 9. So if you wanted to approximate, you could say, well, the distance is about maybe 8.01, and that would be your distance.